All right, distinct roots of constant coefficient, second order, linear, homogeneous ODEs. Don't think there's enough adjectives for these types of problems, okay? So you have constant coefficient, it's a second order, it's equal to 0, so that's the homogeneous part of it, and it has the linear form, all right? So we want to find the general solution to this. So this one's quick, okay? Remember, we have the characteristic equation, okay? The characteristic equation is what? This thing says this is going to be r squared plus 4r plus 3 is equal to 0. And then the roots of that are going to determine the solution type for this type of ODE. Okay, so what do I notice? This factors as what? R plus 3, R plus 1. So that means my roots are minus 3 and minus 1. Okay, again, distinct roots, they're real and distinct. Okay, so that means that my solutions are what? E to the 1 root minus 3t and e to the minus t. Okay, those are my two solutions. Now, in the video talking about the Wronskian, and we talk about how we determine if these are linearly independent solutions and all that kind of stuff. But those are my two solutions. They are linearly independent, so go check out that video. Okay? But e to the negative 3t and e to the minus t, all right, so what's my general solution? The general solution will be y sub h, okay? I call it y sub h because the h is that this was homogeneous, okay? You can just call it y of t, that's fine. It's going to be some constant c1 times one of my solutions, e to the minus 3t, plus c2 times e to the minus t. That's it. Okay, so that's simple. You find the roots of the characteristic equation. This is a quadratic, so you can use quadratic formula, factor, complete square, whatever you want to do. Find those solutions, take their linear combination. That's your general solution, okay? So this has a lot to do with linear algebra. This is really just taking the span of these two vectors. Yes, e to the minus t and e to the negative 3t are vectors. Okay, so check out some of the videos on linear combinations and spans of these different things, as well as generalized vector spaces. But at the end of the day, we just found the general solution to this second order, constant coefficient, linear, homogeneous differential equation. All right? Again, like, subscribe, comment down below, ask me questions, and I'll keep posting videos.